Okay, this is just a brief recap of chapter 1. So we have two different kinds of variables that we've continually talked about, categorical and quantitative. Categorical um, are things that would put you in categories. So like your eye color. So all the people with brown eyes would be in a category, and green eyes would be in a category, and blue eyes would be in a category. So if we have categorical data, we're going to make bar graphs, segmented bar graphs, mosaic plots, or pie charts. And then quantitative variables would be numerical. So that would be like income or, oh gosh, all sorts of things like IQ score, ACT score, stuff like that. Anything that we'd be interested in the average of. So if we have quantitative data, we would do dot plots, stem plots, box plots, histograms, and relative frequency histograms. And also what are called relative cumulative frequency histograms. That, not histogram, but a graph, relative cumulative frequency graph. That would be known as an ogive. I'll show you how to read one of those too. And things that you need to be able to talk about would be the mean, median, standard deviation, range, IQR, and quartiles. And then if you're told to describe, you're going to use that acronym CUS. So, a couple of things. Here is an ogive, that relative cumulative frequency graph. It's kind of like based on a histogram, but like connecting the tops of the bars, sort of. So here's how you read it. If I want to know what score corresponds to the 90th percentile, the y-axis, those are the percentiles. So if I want to look at the 90th percentile, maybe I will try to get like a nice horizontal line here. Okay, let's see if this works. 90th percentile would be somewhere around there. And so what I want to do is look to see where it hits the graph, and then I'm going to look from there down. So if I eyeball down from there, I would say like 52 would maybe be the score. Okay, let's say that a student got a 32. What percentile would they be at? So now I'm given information about the x-axis. So if I was to draw a vertical line at about where I thought 32 might be, you know, and it's not perfect, you're eyeballing, so 32 would maybe be more like here. If I look at that point and then I go across this way, that'll tell me about what percentile I was at. So to me, it looks like pretty close to the 20th percentile, but maybe a little bit higher than that. So I'm going to say like the 22nd percentile. I'm just eyeballing it. Okay, and then if it asks you where the center of the distribution is, what you need to remember is, well, what percentile is the center at? The center, whoops, I didn't mean to move that. The center would be at the 50th percentile. So what I would do is start by looking on the y-axis at the 50th, draw a line over, like a horizontal line over. Try to get one here. Okay, and then I'm going to look to see where it hits the graph and then look down to figure out what the score would be. So the score looks like maybe 42. Okay, let's pretend they asked you about the IQR. Well, what you got to remember is IQR is Q3 minus Q1. And in terms of reading it on this graph, just like we knew that the center was at the 50th percentile, Q3 would be the 75th percentile. and Q1 would be the 25th percentile. So what I would do is I would take my horizontal line, if I can grab it. It's a little tricky on this. Okay, so I would move it up to the 75th percentile, and I would say that that hits right about almost 45. You know, maybe we'll just go with 45. And then we're going to take and move that horizontal line to the 25th percentile, which is Q1. So right about there. It hits the graph here. Oops. Right about here, which looks to me like, oh, I don't know, let's say 33. How about? So if we do 45 minus 33, it looks like our IQR would be 12. Okay, so that's how you read an ogive. Oh, you won't have to make one. I don't think they've ever in the history of the AP test had you make one, but you might have to read one. And I'm, you know, at this point when they're reducing it down to 2 questions, this might not be on there at all, but it's good to just review it just in case. Again, when you're told to describe, make sure that you cuss. This is when you have univariate data. That means one variable. So oops, I don't know why I wrote an F. One variable, like let's say that one variable is height, or that one variable is eye color, or that one variable is salary. Then you're going to cuss. So make sure you talk about the center, which is the median. Any unusual points like outliers, and you can calculate those. The shape, and then the spread. So say from minimum to maximum, which is a range of. Remember that the skew goes off in the direction that it's tailing off most. So like this would be skewed to the right because the tail is going more toward the right. In terms of like thinking about skiing down a hill, it's skiing down the green, easy, gradual hill, not the black diamond. So like this tails more off to the left. And then this one, you could say it would be roughly symmetric, I would say. Okay, mean versus median, and talking about which one would be more robust. Let's say that I gave you, let's see here, I think, oh, this was the page I wanted. Okay, I got off on a different document. Okay, so this is the same page. Talking about which one is more robust. All right, well, let's say that we look at this list of numbers here, and let's say we calculate the mean for that. So 1 plus 3 plus 6 plus 8 plus 10 plus 10 divided by, how many terms are there? 6 terms. Sorry, here. Okay, I am getting a mean of 6.33. Okay, and the median would be the middle term, as long as they're in order, which they are. So if I would cross off, these two numbers are in the middle, so I would need to average those. So I would have a median of 7. Okay, well, now what would happen if I introduce in another number? Let's look at what the mean and the median would be now. So now I would add all these up and add on the 80. And now I need to divide by 7 numbers. And now my mean is 16.85, no, 0.86. And now what is the median? Move that out of the way. Okay, now if we do the canceling off thing, my median is 8. So, which of these didn't change as much? The median didn't change very much. That is the one that's robust. Okay, so it's the center of your data. It doesn't change very much. And I threw in what could potentially have been an outlier. This 80 was a way bigger number than the rest. So that outlier didn't really change the median too much. It really did affect the mean. So that high outlier brought the mean up closer to it. Let's see. Let's answer this question right here. Let's say we have a mean of 31 numbers, and I know that that mean is 26.3. So I know that 26.3 would be equal to the total divided by those 31 numbers. I could solve for that total because I don't know what that would equal. So I could multiply 31 times 26.3 and I would get 815.3. So now it's saying, well, what if I add 30 to the list? What's the new mean going to be? Well, I would take, in order to get my new mean, I would take the total that used to be on the top, which I now figured out was 815.3, and I'm going to add the number 30 to that list. But now, just be careful, I don't have 31 numbers, I now have 32 numbers. So now I can plug those in and figure out my new mean. So 815.3 plus 30, and then divide that by 32. Now my new mean is 26.42. Okay. Let's move on and see what's next. Oh, here's just some more things that we've already kind of touched on. The range is the max minus the min. The IQR is Q3 minus Q1. I think a really important thing that will most likely come up on the AP test is the idea of standard deviation and how to interpret it. So you really have to know your stats to explain what a standard deviation is. And I'm thinking that that is the kind of stuff that's going to come up on the AP test. So here is what standard deviation is. It's roughly the average distance from each point to the mean. So let's go back a page. So in my original data, like this list of numbers here, before I had the 80, well, actually, let's just use the 80. Okay, hang on, let me get this out of the way. Okay, let's use this entire list of data, even with the 80. Okay, so here was the mean and the median for that list. The standard deviation would be roughly the average distance that each point is away from the mean. So like 1 away from this mean. Okay, so like about 15.86 is the distance. And then 3 away from this mean would be like 13.86 is the distance. 6 away from the mean would be 10.86, that would be the distance. 8 away from the mean, 10 away from the mean, 10 away from the mean, 80 away from the mean. If you found all of those distances, each of these points is away from that mean, and then you found an approximate average of all of those, that's the standard deviation. And it's roughly an average. It's approximately an average. It's not a pure average because we're dividing by n minus 1 rather than just an n. But it's pretty close to an average. Okay. Standard deviation, again, using that idea of being the distance from the mean. In all of these examples, the mean is 5. Okay, and so, like, do you see how in this graph the dots are farthest away from 5? That would have the largest standard deviation. So that would be group 1. And then do you see how in group 3, a lot of the dots are right on top of the mean? So all of these distances away from the mean would be 0, which would really bring down your standard deviation. So since they're clumped more around the mean, this would have the smallest standard deviation. And then group 2 is kind of evenly spread out, so that would be in the middle. I've had this in some of the other videos, but just to recap how to get outliers, I would write this down on your note sheet. Anything below Q1 minus 1.5 times the IQR would be considered an outlier, and anything above Q3 plus 1.5 times the IQR would be considered an outlier. So here's some data right here. I typed it into my calculator. Let's see if I still have it in there. Possibly. Okay, yep, I think this is the list of data. Yep, that looks right. Okay, so I typed in these numbers, and then if you go to a blank page and you do menu 611, I have one list. I called my list O. Hit OK. All right, right here is your 5-number summary. Your minimum, Q1, median, Q3, and maximum. So what I did is I wrote those out here. And I'll just label them really quick. This was the minimum, Q1, the median, Q3, and the maximum. So if I want to find outliers, I need my IQR, which is my Q3 minus Q1. So my IQR is 3.5. So if I do Q1 minus 1.5 times the IQR, that would be 24 minus 1.5 times 3.5. All right, so figure out that lower bound. So put that in your calculator. And you're going to get 18.75. So anything below 18.75 would be an outlier. All right, and then we're going to look at our upper bound. So I would take Q3 plus 1.5 times the IQR. So that would be 27.5 plus 1.5 times 3.5. All right, and I get 32.75. So anything above that would be an outlier. Now, if they ask you to give numerical justification, here's your numerical justification showing how you plugged in the numbers. But then if they ask you, are there outliers, they want to see what these boundaries are. So make sure you talk about what the lower bound is and what the upper bound is, like the cutoff for outliers. Don't just mention one or the other. You know, there might only be a high outlier, but you should still mention what the lower cutoff point would be. And then you could go through here and you could try to find, like, are there any numbers smaller than 18.75 or greater than 32.75? But if you don't feel like hunting and pecking, remember you can order your data. So if I go up to where I labeled it and then I do menu, actions, sort, sort ascending. That might make it a little easier to see if there are any numbers below. So it looks like 15 is an outlier. And then if I keep going to look at my highest number is 29. So no, there's no high number, there's no high outliers, just 15. Okay. Okay, moving on. Okay, this is a topic that will most likely come up on the AP test. It almost always does. Let's say you're given a list of numbers. And then oftentimes what you'll do is it'll be asking you something about the mean or the median or the range or maybe the IQR or the quartiles or anything about the 5-number summary. And then it might say something like, oh, there was a mistake in the lab and it wasn't calibrated correctly. And so in order to fix it, we need to add 5 to all the values. Okay, well, you can certainly add 5 to all of these, add 5 to 1, add 5 to 3, etc. So then I would get these new numbers in blue here. And then it might ask you something about like, what's going to happen to the mean and the median or the range, like what's going to happen to the measures of center or the measures of spread. Now you could certainly type these numbers in your calculator and then tell your calculator to add 5. So let me see if I did that in any of these. Yeah, okay. So here's what I did is I typed in this original list right here, and that's my X list. And then here I told it to add 5 to all of the X's, and so it did that right here. And I labeled it Y. And then I found, I think on this page, these are my 5-number summaries for that Y list. So I can go through all that work. And what I'm going to find is that all of these values, so can you see the mean? Oh, I need my pen. Okay, the mean, do you see how that increased by 5? The median increased by 5, but the range stayed the same. Okay, so like the span of numbers from 1 to 8 is 7. The span of numbers from 6 to 13 is still 7. All we did was take those data points and just shift them all to the right. So the range is the same, but my mean and my median went up by 5. So these are measures of center. And your measures of center will just get added whatever they tell you to, but the measures of spread stay the same. So that is when you are just adding on or subtracting a value. Your measures of center will change, but your measures of spread will not. That's when you're adding or subtracting. Okay, so I would not need to type these in my calculator and do menu 611 if I understand the fact that my measures of center change. So if they tell me to add 5, I'm just going to add 5 to here and I'm going to add 5 to here, but I do not add 5 to my range. Okay, now what's going to happen if you are told to multiply by 2? So maybe they're telling you to convert. Maybe they're converting from like inches to feet, or centimeters to inches, or whatever. It might be a conversion that might involve multiplying. So sure, I could take all of my original data and I could multiply by 2 and I will get all of these numbers. Okay, and then they might ask me what's going to happen to my mean, median, range, or IQR, whatever it might be. I can certainly type these in my calculator and do menu 611 and look, or I can just realize what's happening here. Do you see how this number right here changes to 8.28? It got multiplied by 2. 4.14 times 2 gives us 8.28. This number, 5, gets multiplied by 2 to give us 10. And this number, 7, gets multiplied by 2 to give us 14. So everything got multiplied by 2. Okay, so even the measures of spread and the measures of center all get multiplied. So here's a little summary, okay? If you are adding or subtracting, every number in a list by something, the measures of center will get added or subtracted, but the measures of spread will stay the same. If you are multiplying, or technically dividing, every term in a list by the same number, the measures of center and the measures of spread get multiplied by that same amount. Now, if you're wondering what is considered a measure of center, that's your mean, median, quartiles, minimum, and maximum. Measures of spread would be your IQR, range, and standard deviation. This would be an important page to put on a note sheet. Because I really think this is likely to come up. Okay, going back, I would put these formulas on a note sheet. And I would put the interpretation of standard deviation on a note sheet. Maybe you could start accumulating a sheet of just like interpretations. And then as we go along, you can have the different interpretations of things. So like standard deviation is definitely going to be one of them. There's going to be so many. So just kind of maybe start making a note sheet just for interpretations. Okay, so that's just a real quick recap of chapter 1. And that's it for now. Have a good day.